St. Joseph College for Women, Autonomous, Vishakhapatnam. Welcome to St. Joseph Open Web-based learning platform, So E-Learn, for a soulful and enriching e-learning experience. Department of Chemistry presents St. Joseph's massive open online course, Solid States. Physical Chemistry, Module 3, Chapter Solid States, presented by Dr. B. Madhavi, MSc, MPhil, PhD, Department of Chemistry, St. Joseph's College for Women, Autonomous, Vishakhapatnam. Contents 3.5 Law of Constancy of Interfacial Angle 3.6 Law of Rational Indices 3.7 X-ray diffraction and crystal structures. Laws of crystallography. The geometric crystallography is based on three fundamental laws: law of symmetry, law of constancy of interfacial angles, and law of rational indices. The law of symmetry was discussed in the previous video. The second law is law of constancy of interfacial angle. It is the angle between adjacent faces of a crystal is called as interfacial angle. The angle between two corresponding faces of a crystal of the same substance is always the same. The internal arrangement of the atom in a crystal is fixed. The size and shape of the crystal depends upon the condition of the crystallization. This law is also called as first law of crystallography. The size and shape of the crystal of a compound varies with the condition of crystallization, but the angle between the faces remains constant. The crystals of same substances can be having different shapes. It depends on number of angles and sizes of faces, but the corresponding faces remains always equal. Third law, law of rational indices. The ratio between the intercept on the axis for the different faces of a crystal can be expressed by rational numbers. It is possible to choose along the three coordinate axes with unit distances, not necessary of the same length, such that the ratio of the three intercepts of any plane in the crystal is given by HA, KB and LC, and all are in A is to B is to C ratio or HA is to KB is to LC ratio. Here HKLR can be same as those of unit plane. They can be simple whole number multiples of those of the unit plane. One or such intercept may be infinite. If the face is parallel to one or two axes, that means the face does not cut one or two axes to the intercept made by the unit plane along the crystallographic axis. As shown in the figure, the intercept of the plane with the crystallographic axis are equal and the intercepts are arbitrarily chosen to be A, B, C along respective X, Y, Z axis. Weiss indices and Miller indices. Indices are nothing but indicators of crystal plane. The Weiss parameters introduced by Christian Samuel Weiss in 1817. It helps us to determine the distance between the parallel planes of the crystal, or it is characterized and represented by any plane of the crystal. These indices are ratio of intercepts on that axis to the unit length of the axis. These indices is equals to intercept of the axis divided by unit length of the same axis. These indices are generally whole number and may be fractions of whole numbers as well as infinity. Some of the conditions of the Weiss indices are three axes present, namely A, B, C values. That means the Weiss indices are indicated by A, B and C. They can be fractions, integrals, positive, negative, or infinity, but they are not equals to 0. The conditions for positive and negative V synthesis. If origin to right, then V synthesis is positive, and origin to left, then V synthesis will be negative. If origin to front, then V synthesis is positive. If origin to back, then V synthesis will be negative. If origin to up, then V's indices is positive, and origin to down, then V's indices are negative. Origin cannot be present along with the plane. Miller indices. It was proposed by William Hallowes Miller in 1839. Miller indices are the mathematical notations to represent crystal plane and its direction in crystal structure. Miller indices of a plane are the reciprocals of the distance from the origin at which a given face intersects the three axes. In Miller indices, the HKL values is used for different axes instead of x, y, z axis. That is, x is replaced by h, y is replaced by k, and z is replaced by L value. Miller indices are obtained by taking the reciprocal of V's coefficient and multiplied by the smallest number that will express all reciprocals as integer. Here h is given by a by intercept of the plane along x-axis, and h is also equals to b divided by intercept of the plane along y-axis, and h is equals to c divided by intercept of the plane along z-axis. Longer the value of Miller indices, smaller will be the value of intercept of that plane along the given axis when it is 0. The plane is parallel to the axis. Two parallel planes in crystal have same Miller indices because they are equally spaced parallel planes. To calculate Miller indices, the following selections are given. Rule 1. As per definition of origin, origin should be left or left, down and back. Rule 2. Find the intercept of the respective axis x, y, z, which are otherwise called as HKL. Obtain the reciprocal of V's indices. Eliminate on the fractions to make them integrals or a whole numbers. Miller indices of the plane are called as HKL. The origin is never considered on the plane because it considers intercept and it will become equals to 0, and thus Miller indices will become infinite, but we know that Miller indices are never infinite. Origin is considered or fixed on such a point for which point in one step we should reach or move to it from plane. Or in other words, we may say that distance of the plane from origin should be unit. X-ray diffraction in crystal or XRD in crystal. X-ray diffraction or X-ray crystallography is used to determine the crystal structure, atomic and molecular structure by interpreting the diffraction pattern formed when X-rays are scattered by the electrons of atoms in crystalline solids. XRD is a powerful technique used to determine the atomic and molecular structures of a crystal. X-ray diffraction is the scattering of X-rays by regular spaced atoms in a crystal lattice. When X-rays hit a crystal, they are diffracted in specific direction. By measuring the angles and intensities of these diffracted beams, one can deduce the crystal in three dimensions. X-rays are sent through the crystal to reveal the pattern in the molecule and atoms. X-ray crystallography works based on X-ray diffraction principle. It means that the scattering of X-rays are done by crystals. X-ray diffraction is based on constructive interference of monochromatic X-rays and a crystalline sample. Every crystalline substance gives a pattern. The same substance always gives the same pattern, and in the mixture of substance, each produces its own pattern. X-rays are directed at a crystal sample. The atoms in the crystal causes the X-rays to diffract. Constructive interference occurs when the path difference between reflected ray satisfies the Bragg's law. Diffraction. It is the process by which a beam of light or other systems of waves is spread out or bending of electromagnetic radiation as a result of passing through a narrow edge, typically accompanied by interference between the waves that are formed. Diffraction is also defined as bending or spreading of light waves when they pass through a narrow slit. This causes the light to spread out and produce a pattern of bright and dark fringes on the screen. It becomes more noticeable when the size of the or slit becomes obstacle, and it is comparable to the wavelength of the light. Dark bands are observed due to constructive interference. Diffraction takes place with electromagnetic radiation like light, X-rays, gamma rays, and with very small particles such as atoms, neutrons, and electrons, which show wave property. Interference of light. It is the phenomena in which two waves superpose to form the resultant wave of lower, higher, or same amplitude. The most commonly seen interference is the optical interference or light interference. Constructive interference. It occurs when the maximum or minima of two waves add together. The two waves are in phases, so that the amplitude of the resultant wave is equal to the sum of the individual amplitude. Constructive interference occurs when two waves meet in such a way that their peaks or the bottom matches perfectly. Destructive interference. This occurs when the maximum of two waves are at 180 degrees or at out of phase. In this situation, the positive displacement of one wave is perfectly cancelled by the negative displacement of the other wave, resulting in a combined amplitude of zero. Destructive interference happens when two light waves meet in such a way that their peaks and troughs cancel with each other. One wave has a crest up and other wave has trough down. If both the crest and trough cancel with each other, then resultant wave will be zero or a weaker wave. Thank you for listening to my presentation.